Hi, this is the data automation ETL pipeline project that we did in collaboration with the UNCW Division of Advancement for Computer Science 450 Software Engineering. I've served as project manager. My name is Rachel Jones.
And I'm Dylan. I was the lead developer.
I'm Gabriel, and I was just a regular developer.
My name is Mateo, and I was also a developer.
My name is Nikolas. I was also a developer.
So the original problem that the University Division of Advancement was having was that they had a very old database. And then whenever they extracted data from that database, it would come completely schemaless. They wouldn't really be able to use it for anything. They really wanted to make data analytics and dashboards and whatnot, but they just really weren't able to do it with the database that they currently had. So they had to move it to AWS, but they were only able to do this process once a month because it took so unbelievably long. It was incredibly manual. And so then we realized that, well, we were assigned that we had to kind of automate this process for them. And so originally we were thinking of this UI that was help generated by Nikolas that we will show on the screen now.
The UI looked like this at the beginning. We had different options on the left side, like dashboard, error logs, the documentation, pipeline editor, and to change the settings. We had these like quick actions, which shows which lets us update the queries, make manual data extraction, or update outdated data. This was the most of this stuff was without function, just as an idea, as the UI first. We had a little overview about our last archive, the next schedule, query verifications and errors. There was a little system activity log and upcoming runs. This is basically everything from the next parts together. The error logs, they are looking very similar to the final ones in the Airflow. We can like see every single console log with its time and if it's an error, warning, or success. In the documentation, we wanted to add like the stuff which is now in the document or the documentation file, so the user can just type something in and see if there's something in the documentation about it, to look that up very quickly, but there's not more. With a click on the pipeline editor, we can enter Airflow directly, which replaced the entire UI. And on change setting, we'll be able to make general settings in the system, and we had a query selector to access the data by using SQL selections.
So we're back. This was what we actually ended up with, though. So we kind of realized that we probably shouldn't reinvent the wheel, and we ended up building our application based off of Apache Airflow, which is a really well-used workflow orchestration program.
Yeah, so I did the initial implementation for Apache Airflow, and basically it gave us everything that we saw from the previous UI, but already pre-built for us, open source, all that kind of nice stuff. Gives us the ability to do scheduling, has workers, trigger, logger. It's easier to use for non-technical people, and you can set up other things like OAuth and store credentials, and I believe environment variables as well.
Mm-hmm. And we also kind of Dockerized Airflow, because Docker and Airflow just have a lot of integrations that are documented upon, and we were having some issues with how to set up Airflow across devices. So this was the easiest way to make it the most portable and most easy to use, especially for non-technical people.
And then I also worked on extracting the raw data from the FTP server. So we were given access to their FTP credentials, and basically I just used Python and Paramiko to access the client and pull all the raw data that we needed from there. This also implemented using environment variables and pulling those in via Python.
So the way that I transformed the CSVs, I put them in UTF-8 format. I applied file-specific transformations like date formatting, numeric cleanup, zip code padding, and fiscal year logic. And I automated the batch processing for every file in the raw data folder. And then we tested them all on sample data sets.
Later on, we consulted with our stakeholders and customers, and we decided on making a YAML configuration file in a Python engine. I worked on creating the YAML configuration, and how it worked was we took the transformation file, took the instructions and changed them into YAML instructions that the Python engine would then read through and then apply the changes to the CSV file while also transforming the file into a UTF-8. The reason for this was to separate the business logic and programming logic, and it would allow us to inject the instructions into the code and change the instructions without needing to go into the program.
Next was our staging area. So staging areas are kind of just needed in ETL pipelines. So we were given the S3 bucket by the school for credentials. So we would feed the CSVs into the S3 bucket one by one, and it's using Boto 3, which is basically just Python for AWS. But we actually had a bit of an issue as far as getting S3 credentials. So we ended up having to use a free tier S3 bucket to just kind of, and synthetic CSV, so to not go over the free tier, to just test things out so we could really hit the ground running whenever we actually got the credentials in. And our next was the load. So basically this would map table names to Redshift. So you get the CSV names, cut off the CSV and map the table to Redshift in order to get the names and then load them in that way. It's a pretty dynamic thing of doing. So each table that you're loading in gets a different task. We also ran into issues with this as far as getting credentials. We really weren't able to get credentials until very late into the project. And we just kind of ended up using just a simple YAML copy in order to get the files in Redshift.
Yeah, so the original plan was to hash directly into the S3 buckets, but then we realized that the files in the S3 bucket actually expire after 3 days. So we had to discard it and then use Redis, which allowed for a persistent storage system. We also don't really need time optimization because our pipeline's not very big. And as Rachel had said earlier, we got credentials much later than we wanted. So all of it was just a backed up by a time crunch that we were under, unfortunately.
So I did some logging as well. The initial logging, we stored the files locally onto the machine and then also printed them out to the user through the console. But we realized once we were going into Airflow that Airflow had its own built-in logging methods that would allow remote log storage, allowing other users to be able to see the logs of previously ran pipelines that happened on other devices. We also developed a configuration file in case there were issues on a machine to store the logs locally so they can be uploaded later. We also originally planned to have email events in case of a failed pipeline, but due to issues with the SMTP, specifically on the IT side, there were restrictions. We were not able to implement this in time. We also had the customers also mentioned a possible change from Airflow because they did not want to change what they were using. They wanted to stay consistent throughout all of their workflows with other campus, with other
Their built-in
campus.
infrastructure.
Yes.
Yeah. Our communication with the customer was very good. We agreed on regular meetings like every 2 or 3 weeks. We talked about our progress and different features we want to add later. For example, making the refresh every night instead of monthly or weekly.
Yeah, and we also showed them live demos and kind of gathered our requirements for the next sprint in order to figure out what we needed to integrate, what was left. This is our version of Dockerized Airflow. You could sign in with GitHub. That is my wrong GitHub account. If I can. So then this would show the UI. This kind of will show the runs and the failed and whatnot. And it's a kind of an intuitive UI. We really kind of liked it. We kind of realized, oh, our old demo really did not have this much in depth. It wasn't, this is specifically made for things like this. So it was very useful. You can have connections configured within it so that people who are non-technical can literally make these connections and then replace them. For example, if maybe a credential expires, it gives them a really good option of doing it instead of directly modifying an end file. It's much more configurable. As you can see, it shows that it failed. Now, this isn't completely accurate because I'll go into a little bit more detail with, but we've been having issues as far as credentials and with Redshift. So one really big thing is you see the mapping and the get files from FTP do work. You can kind of, we have an intuitive logging that Gabe made that will show all of the CSVs going in and that the fact that they were extracted. But the real issue that we're having is you see these failed. The reason that they failed was because of this, which is an error with the VPN. And so this is an issue that we've been running into as far as with Docker. In an ideal world, Docker would have something giving it permissions to the VPN, or it would even be hosted on kind of virtual machine instance that was directly interlinked with the VPN host kernel. But unfortunately, we really weren't able to get that. And so our only workaround was really to undockerize it and use it on an Airflow standalone. So this is showing it right here. So this is the old version, which is why the UI looks a lot more old. But it pretty much has the exact same things going. This was kind of a little bit more of a POC that our code actually does work all the full way. And it can be done, especially since we've been running into so many issues as far as working with IT and getting credentials and whatnot. So I can show, I think it's this one. These were skipped a little bit for some file issues, but you can see kind of the mapping. It's a little bit different, but these all succeeded. You have them going into the S3 bucket. And it doesn't show the logs now because, again, of the VPN error. If there's anything specifically in the logs associated with accessing it through VPN, even though I'm on a VPN right now, since it's not the old one that I originally used when I was running this, it can't go back on. So that's something that could also be a possible future enhancement. I'm not really sure if a workaround, but at this moment. But as you can see, even though that says that failed, they were all successes. The only reason that these three failed, which again, I wouldn't really be able to go into the logs, but the reasons that they failed was because the CSVs would be plural and then the table names within Redshift would be singular. So it really was kind of more of an error on the person who made the table side, and we kind of talked to them and they said that they would rather rename the tables than us configure the code specifically for that error, just because it's kind of good practice for them to just rename the tables for it. But also with the code, you can kind of see within it that it will really make sure that you do the entire order of operations. This kind of shows the forces sequential tasks. And I just think the graph is really nice to be able to show on each run exactly what succeeded and what failed. And one thing that's also really nice about Apache Airflow is it can kind of run things a little bit in parallel. So if I were to run this again and trigger it again, it'll also tell you what you're running on, what is queued. So after this fully runs through, this will go, and then it'll go this, and then this, and then this, and this. So it's just kind of very clean and organized with that, and a really nice UI, the fact that it'll show you, and you can kind of click on it and see logs within real time.